Hi everyone. Now we discuss the topic rank correlation coefficient. Rank correlation coefficient. Rank correlation coefficient. Already in the last class we discussed the correlation coefficient. But what is the difference between correlation coefficient and rank correlation coefficient? In the coefficient of correlation or correlation coefficient, we have to check whether whether there is any relationship between the two variables or not. Here in the rank correlation coefficient, we discuss about the correlation coefficient between the ranks. What is rank? If we consider two variables x and y. Now we have to find the rank correlation coefficient between these two variables. Here we have some observations for x variable and some observations for y variable. How to calculate the rank correlation coefficient? First we assign ranks to these variables. If suppose x has some observations and y has some observations. Okay, we have to assign the ranks for the given observations. How to assign the ranks? When we give the first rank, for the highest marks we give the first rank, next highest mark second rank, next highest marks third rank, like that. For these observations also, highest value we can assign first rank to the highest value and second rank to the next highest value, third rank to the next highest value. Okay, individually we give the ranks to the x values and ranks to the y observations also. What is the formula for rank correlation coefficient? Here the rank correlation coefficient is denoted by rho. It is denoted with the symbol rho and it is defined as 1 minus of 6 into summation of di square by n into n square minus 1. This is the rank correlation coefficient in terms of different ranks, distinct ranks, if there are no repeated ranks. Okay. So for distinct ranks, the rank correlation coefficient is given by the formula rho is equal to 1 minus of 6 into summation of di square by n into n square minus 1. Here n is the number of observations. Here n is number of observations. And di is the difference between the ranks. Difference between the ranks. It is given by rank of xi minus rank of y. Here xi's are the observations for x values and yi's are the observations for y values. Here we assign the ranks to the each and every observations. The difference between the ranks of x and ranks of y is denoted by di. Okay, now we substitute n value and di values here. Then we calculate the rank correlation coefficient. This formula is used in case of distinct ranks only. If suppose there are repeated observations, then we assign the same ranks to the repeated observations. In such cases, how to find the rank correlation coefficient? There is a small difference. In case of repeated observations, the rank correlation coefficient is given by rho is equal to 1 minus of 6 into summation of di square. Up to this one is common to all. In addition to that, we have to add the extra factor to summation of di square. That factor is m into m square minus 1 by 12. For each repeated observation, we have to add this factor. That means if there are two repeated observations, then we have to add the two factors, m into m square minus 1 by 12 plus m into m square minus 1 by 12. If there are three repeated observations, then we have to add three factors like this terms. Okay, here what is m? M is the number of times. Here m is the number of times the observation is repeated. Observation is repeated. Okay, this is about the rank correlation coefficient. Okay, this is for different ranks and this is for repeated observations. That means it is repeated for repeated ranks. In case of repeated ranks, we calculate the rank correlation coefficient. Rho is equal to 1 minus of 6 into summation of dA square plus m into, here we are adding the factor m into m square minus 1 by 12 for each of the repeated observations. Okay, here m is the number of times the observation is repeated. Okay, in this we discuss one example for different ranks and for repeated ranks. Okay, I am giving some observations to x values and y values. For x and y variables, we have to assign some observations. Now we have to calculate the rank correlation coefficient for the given two variables. This rank correlation coefficient is developed by Spearman. Spearman. He is one of the science statistician. He developed the concept rank correlation coefficient. That's why this rank correlation coefficient is also known as Spearman's rank correlation coefficient. Okay. Now we discuss one example. Here I am taking the values for x and y. Suppose x is the marks in mathematics and y is the marks in statistics. Okay, here x is suppose 56, 48, 72, 65, 92, and next is suppose 85. Here I am taking 6 values for x. Similarly, we assign some values for y also. 62, 58, 91, 75, 98, and next this is 73. Okay, here also I assign some of the values for x and y. In x values, there is no repeated observation. These are all values are distinct. In the y values also, there is no repeated term. So these y values are also different. So we assign ranks for these x and y values. We take x values here in a column wise: 56, 48, 72, 72, 65, 92, 85. Now we have to assign the ranks for these observations, rank of x. In these observations, what is the highest value? Here 92 is the highest value. So we assign first rank for this observation. Next highest value is 85. So now we have to assign second rank for this observation. And next highest value is 72. So we assign third rank for this observation. And next highest is 65. We assign fourth rank. Next highest is 56. So fifth rank. And 48 is next value, that is the sixth rank. Okay. Now we assign the ranks for each of these observations. Next take the y values. Here y values are 62, 58, 91, 75, 98, 73. Now we assign the ranks for y. What is rank of y? Here also same. In these values, what is the highest value? 98 is the highest value. So we assign the first rank for this observation. Next highest is 91. We assign second rank. Next highest is 75. We assign third rank. Next highest is 73. We assign fourth rank. 62 is the next highest. So we assign fifth rank. 58 is the next value. So we assign sixth rank. Okay. For each of the y values also we assign the ranks. These ranks are also different. Rank of x is different and rank of y also different ranks. Now we calculate the difference between the ranks, di. Di means rank of xi minus rank of yi. Di is the difference between the ranks of xi and rank of yi. Okay. Now we have to now we take the subtraction of these two columns, rank of xi minus rank of yi. 5 minus 5 we get 0. Next 6 minus 6 we get 0. 3 minus 2 we get 1. 4 minus 3 we get 1. 1 minus 1 we get 0. 2 minus 4 we get minus 2. These are the DI values. For calculate the rank correlation coefficient, we have to find DI square values. So next we calculate DI square. That means the square of these DI values. 0 square 0, 0 square 0, 1 square is 1, 1 square is 1, 0 square is 0, minus 2 whole square is 4. Add all these values, DI square, 0 plus 0 plus 1 plus 1 plus 0 plus 4. We get 6. Summation of DI square is equal to 6. Okay. Summation of DI square is equal to 6. Now we calculate the rank correlation coefficient rho. Rho formula is 1 minus of 6 into summation of DI square by n into n square minus 1. Okay, 1 minus of 6 into summation of DI square value is 6 by. Here n is the number of observations. How many observations are there overall? There are 6 observations. So n value is 6. Substitute n value 6. 6 into 6 square minus 1. Here 1 6 get cancelled. So 1 minus of 6 by 6 square minus 1. 36 minus 1 is 35. 1 minus 6 by 35. That is 35 minus 6 by 35. We get 29 by 35. We calculate this value using calculator. Use calculator to find the value 29 by 35. Or leave this fraction as to no problem. So 29 by 35. We get the value 0.8285. 0.8285. This is the rank correlation coefficient in case of distinct ranks. Okay. This is about the rank correlation coefficient in case of distinct ranks. Here the observations are repeated. So we assign different ranks for each of the X observations and Y observations. We have to find the difference between the ranks and square of these ranks. Okay. And then substitute all these values in the rank correlation coefficient formula. Next we have to find the rank correlation coefficient in case of repeated observations. Okay. Here I am taking again 6 values, X and Y values. Here I am taking X values and Y values. I am given 6 observations to each of these. Here X values, suppose 16, 18, 16, 20, 19, 18. Oh, already it's over. Okay. So 6 values. Next I assign values for Y. Okay. Here I am assigning the values for Y. 15, again 15, 12, again 15, 12, 6. Okay. These are the X and Y observations. Now we have to calculate the rank correlation coefficient for these observations. Okay. How to calculate this rank correlation coefficient? Here observe these X values and Y values. In X values 16 is repeated 2 times and 18 is repeated 2 times. Okay. Observations are repeated, so ranks are also repeated. Next, in Y observations 15 is repeated 2 times and 12 is repeated 2 times. There are 4 observations are repeated. 16 is repeated, 18 is repeated, 15 is repeated and 12 is repeated. 4 observations are repeated. So we have to add 4 factors to summation of DI square in the formula. Okay. For each of the repeated observations, we have to add the factor m into m square minus 1 by 12. Okay. So, first we assign the ranks for these observations. How to assign the ranks for the repeated observations? Okay, I will explain here. Here xi values. Xi values means X observations. 16, 18, 16, 20, 19, 18. Okay. Now we assign the ranks for these observations. How to assign the ranks for these observations? How to assign the ranks? In this, what is the highest value? 20 is the highest value. So, the rank of 20 is 1. Next highest value is 19. So, we assign second rank for this. Next highest is 18. Here 18 is repeated. Here 18 is repeated. How to assign the ranks for this 18 values, 18 observation? Okay, 1, 2 ranks are already completed. Now we have to assign third and fourth ranks for these two observations. But both the observation values are same. So we can't assign different ranks for the same repeated observations. So next assigned ranks is 3 and 4. We have to assign the average value of the 3 and 4 to this observation. The average of the ranks 3 and 4 is 3.5. So we assign 3.5 rank to each of these observations. There is no partiality. This observation is repeated. So we have to assign third and fourth ranks for these two observations. But the observation is same. So we don't assign different ranks for the repeated observation. So we take the average value of the 3 and 4. Okay, that is 3.5. That 3.5 is rank is assigned to this observation. So here ranks 3 and 4 are completed. We can't use again fourth rank. Okay, next rank is already 3, 4 ranks are completed. Next we assign fifth rank. Okay, what is the next highest value? There is only 16. 16. This 16 is also repeated. Okay, already 3, 4 ranks completed. Now we have to assign 5th and 6th rank for these observations. Okay, here also same. The average of 5 and 6, that is 5.5. We assign 5.5 rank for this observation. Okay, so ranks of xi is completed. Next, take yi values. Here yi 15, 15, 12, 15, 12, 6. What is the rank of y? Rank of y. What is the rank of y? In these observations, what is the highest value? 15 is the highest value. But 15 is repeated 3 times. Okay. So, which rank we have to assign to these repeated observations? We have to assign, there are 3 observations. 15 observations are repeated 3 times. So, we have to assign the ranks 1, 2, 3 for these observations. Okay. What is the average of these 3 ranks? The average of 1, 2, 3 is 1 plus 2, 3, 3 plus 3, 6. 6 by 3 is 2. So, average rank of 1, 2, 3 is 2. So, we have to assign the second rank for these observations. There is no first rank. Okay. We have to assign the same rank for each of these repeated observations. So, already 1, 2, 3 ranks are completed. That means, already we assigned 1, 2, 3 ranks to each of these observations. Okay. 1, 2, 3 ranks are over. Next, we have to assign the fourth rank. Okay. Fourth rank. We have to assign fourth rank for 12. But here 12 is repeated 2 times. Okay. So, we have to assign fourth and fifth ranks to these observations. What is the average of 4 and 5? 4.5. So, we assign 4.5 rank for these 2 observations. So, 4, 5 ranks are completed. Next, we assign 6th rank to the next observations. So, in this way, we have to assign the ranks for the repeated observations. Okay. Next, we calculate the difference between the ranks. Di. Difference between the ranks is rank of xi minus rank of yi. Okay. 5.5 minus 2, that is 3.5. Next, 3.5 minus 2, 1.5. 5.5 minus 4.5, we get 1. 1 minus 2, we get minus 1. 2 minus 4.5, that is minus 2.5. Next, 3.5 minus 6. 3.5 minus 6 is minus 2.5. These are the difference between the ranks. Next, calculate di square. Di square is square of the di values. 3.5 whole square, that is 12.25. 1.5 whole square is 2.25. 1 square is 1. Minus 1 whole square is 1. Minus 2.5 whole square is 6.25. This is also same 6.25. Now we have to add all these values. Okay, 0.25, 0.25, 0.25, 0.25, 0.25. So that becomes a 1. Okay, 12 plus 2, 14, 14 plus 1, 15, 16, 16 plus 6, 22, 22 plus 6, 28, already 1 is there, 29. Okay, 14, 15, 16, 22, 28, 29. So summation of DI square is 29. Next, in addition to the DI square values, we have to calculate, we have to add the factor m into m square minus 1 by 12 for each of repeated observations. In x values, which terms are repeated, which observations are repeated? 18 is repeated 2 times and 16 is repeated 2 times. 18 is repeated 2 times. So here m into m square minus 1 by 12 factor is equal to, here m is 2, number of times the observation is repeated. Substitute m value 2, 2 into 2 square minus 1 by 12. 2 into 2 square minus 1. So 2 into 3, 6. 6 by 12, that is 1 by 2. 6 by 12, that is 0.5. 1 by 2, that is that value is 0.5. Next, in x value 16 is also repeated 2 times. 16 is also repeated 2 times. Here also the factor value m into m square minus 1 by 12 is equal to 0.5. Next, in x observations, okay, for each of the repeated observations we have to find the factor m into m square minus 1 by 12 value. Okay. Next, in y values 15 is repeated 2 times. Here we are taking the y values. In y values 15 is repeated 3 times. So here m is equal to 3. Now we have to calculate the factor m into m square minus 1 by 12. Now substitute m equal to 3 here. 3 into 3 square minus 1 by 12. 3 into 3 square minus 1 by 12, that is 3 into 9 minus 1, 8. 3 8s, 24. 24 by 12. 24 by 12, that is 2. Okay. In y values, 15 is repeated 3 times. For repeated for the 3 times repeated observation, the factor m into m square minus 1 by 12 value is 2. Next, in the same way, in y values, 12 is repeated 2 times. In this 12 observation is repeated 2 times. Here also the factor m into m square minus 1 by 12 is 0.5. Here m is also same value, so we get 0.5. If m value, if the number of times the observation is repeated, that m value is equal to 2, then we get m into m square minus 1 by 12 value is 0.5. If m is equal to 3, m into m square minus 1 by 12 value is 2. Okay, for each repeated value, we find this factor value. So we have to add these 4 factors to summation of di square in the formula. So we write the formula for rank correlation coefficient and then substitute all these values here. Okay, what is the formula for rank correlation coefficient in case of repeated observations? Rho is equal to 1 minus of 6 into summation of di square plus, here we have to add these 4 factors to summation of di square. M into m square minus 1 by 12 plus m into m square minus 1 by 12 plus m into m square minus 1 by 12 plus m into m square minus 1 by 12 divided by n into n square minus 1. Okay. This is the formula in case of repeated observations. Here 4 observations are repeated. So we have to add 4 factors to summation of di square. That is the only difference. For repeated observations, here we are taking only summation of di square. In case of repeated observations, we have to add the factor for each of the repeated observations. Okay. Now we substitute all these values. 1 minus of 6 into. What is summation of di square? We get 29 plus. First factor value 0.5, second factor value is also 0.5, third factor value is 2 and fourth factor is 0.5. Why? Here n is number of observations. Here we have 6 number of observations. So 6 into 6 square minus 1. Here also 6 get cancelled. 29 plus 1, 30, 30 plus 2, 32, 32.5. By 6 square minus 1, 35. First we simplify this value. Or take LCM and then simplify, no problem. If we take LCM, that is 35. So 1 into 35, 35 minus 32.5. 35 minus 32.5 is 2.5. 2.5 by 35. So what we get? 2.5 divided by 35. So we get 0.0714. 0.0714. This is the rank correlation coefficient value in case of repeated observations. Okay? Are you understand this concept? Rank correlation coefficient. Rank correlation coefficient is developed by Spearman. That's why this rank correlation coefficient is also known as Spearman's rank correlation coefficient. The rank correlation coefficient in case of different observations, that is given by rho is equal to 1 minus of 6 into summation of di square by n into n square minus 1. In case of repeated observations, we have to add the factor m into m square minus 1 by 12 to summation of di square. For each of the repeated observations, we have to add the factor. If there are 4 observations, if 4 observations are repeated, then we have to add the 4 factors. If there are 3 repeated observations, then we have to add the 3 factors. If suppose there are 2 repeated observations, then we have to add the 2 factors, like that. Okay, remaining procedure is same. This is about the rank correlation coefficient. Okay. Next, in the next class, we discuss about the regression. Okay, regression concept is very important for data science students, particularly data science, big data analytics. In case of data, this regression concept is very important. Okay, in the next class we discuss the regression concept. Okay, thank you.